hot topic in many of your classes. And so I'm going to show you the registration PowerPoint that the science department put together. You have a whole whopping 2 slides. One of them says questions on it. It's like in 9th grade, you have to go through all of the iterations, but at this point you guys kind of know how the game is played. So we'll do that. And then you also have your registration sheet that I have to sign off on. I'm not going to do that today. I just sign off on your science selection. So I will do that probably on Thursday, just because that'll do it for every class on Thursday, so I don't get confused or whatever. Does that sound okay? Cool. Yeah.
Wait, I'm taking 2 sciences,
so you can, either one of us can sign off on it. It doesn't matter. Yeah, we'll both be happy to do that, or maybe we both need to. I don't really know. All right, so here is your whopping 1 of 2 slides. Like I said, the other one says questions. It says, I'm in physics, now what? So the answer is there's lots of choices. You can take AP Bio, you could take AP Chem, you could take AP Physics 2 with me, which I would love for you to do. And I think I've told you this before. We did that little survey to see if there was enough interest. And you will be just fine going into it. I know sometimes it seems intimidating, right? Because some of the kids will have taken AP Physics 1 that are going to be in there, but it'll be good because there's no reason for you to take AP Physics 1 because they just studied work also. And they've done they're doing the same things, just at a little bit different pace. That's it. So you won't be behind. So if you are interested in that, if you want a little more physics, that's what you would do. Otherwise, AP Bio, AP Chem, Kirkwood Academy science classes are options as well. Maybe there's other stuff, but I think that's it. Do you guys have questions about that or about how you would choose what to do or anything? Do you know what you're going to do? You have it figured out? No, she's like, no, not at all. Do you have questions for me? Yeah. Okay. Well, if you do, let me know.
Are these some of the really difficult classes right here?
Yeah.
They're difficult.
But you're going to be a senior.
Which one's the hardest?
It depends on you. So I was talking to Oz this morning because we were talking about, I came into chem and whatever. And he's like, AP Physics is super hard. I'm like, AP Bio is super hard. It depends on how your brain works. For me, AP Bio would be much harder than AP Physics because I'm not, my brain doesn't think quite like a biologist does. My brain thinks like a physicist does. So for me, AP Bio would be much more difficult. But for him, he's like, I wouldn't ever want to do AP Physics, so it depends. So AP Bio is going to be a lot more reading. AP Bio is, it used to be a lot of reading and memorization, and that it's not that way as much anymore. So it's more applying this thing to this thing and how would this interact with this system and that kind of stuff. So there's a lot of lab kind of discussion and planning that happens. How would you set up how would you set up this experiment, or how would you take this data and use it? That kind of stuff. But it's also a lot of content. It's a lot of biology content. AP Chemistry is often taught, that's AP Bio, AP Chem, AP Physics are all hard, right? They're all college level science classes. AP Chem is basically the equivalent of the intro chem class that you would take at University of Iowa or wherever. And then AP Physics, it's kind of funny because having gone through physics already, what you've done, the AP Physics course, there are a couple of units that are kind of tough, but a lot of them are very conceptual. So I don't know if you guys remember the list, but there's thermodynamics. So that's talking about heat flow. And a lot of that will be stuff that you've talked about in chemistry as well. There's fluids. So talking about how fluids flow through things and how why things float, stuff like that. We'll also talk about optics. So we'll do light and color and how lenses and mirrors work and things like that. And then my favorite part is is atomic and nuclear. That's the getting into the nitty gritty, the small stuff that I think is just really kind of crazy. Yeah.
So if you pass the AP test, does that mean that you don't have to take it in college, or is that not?
It totally depends on the college. So every college is different. College Board wants you to believe, right, that if you take the AP test and you get a 5 on it, then you wouldn't have to take that in college. But you would have to talk to whatever school you're thinking about going to find out if it would count. Does that make sense? And for an actual credit. That said, I would always encourage people to take the test for 2 reasons. Number one, because you've worked really hard on the content, so you might as well. And number two, and this is the bigger one that I've seen a couple of students kind of get burned by. Oh, well, the school I'm going to isn't going to take the AP exam, right? Like, it's not going to give me credit for it. But then life happens, for whatever reason, you transfer from that school to another school, and that school would have given you credit if you had taken the test. Do you know what I mean? And so, it would be sad not to take the exam if you've already gone through the course. But different schools do have different rules about even different, like some schools will take AP Chem but not AP Bio, and it definitely just depends on school. Yeah.
Chemistry is probably the one that I'm best at, but then my friend was saying that AP Chem was one of the hardest. And people who get A pluses in regular chemistry don't do very well in AP.
So we don't have any data at this point, right? Because we haven't offered AP Chemistry here yet. So we haven't done it at Liberty before. I know that Ellickson works very closely and will continue to with the teacher at West, who she's a colleague of, right, to kind of model after that. So I think that her course will be good. I really do. But I don't know that I could say, that it would be, that they're definitely not going to do well. Or I think you should take the class that you're most interested in the content of. Yeah. So, does that make sense? Other questions that you have? Good questions. And I don't even know what's offered at Kirkwood in terms of sciences. I don't know if you guys know, but if you're at all interested in that, I would say talk to your counselors, and they can help you out with that. So, yeah. Cool. If you have more questions, let me know. We can certainly chat another day or later today or whatever. This was your other slide. There you go. Now you've got it all, right? Yay for us. All right, let's do physics. So my plan for the day, we've got a lot of things on the list. We're going to get through as much as we can, as per usual. First thing on the list is to go over homework. Do you guys have questions on the homework? And if no, then we can move on. They were all conceptual questions, I think, if I'm remembering correctly, right? So if you did them, hopefully they were pretty straightforward.
It's like a lot of work.
But what class are you talking about? Yeah.
It's like
Questions on homework or no? Okay, pull out your notes if you know no more questions. We'll jump in and get started. We were almost done with this example, or maybe we even finished it yesterday. I cannot completely remember. I feel like we were talking about Leanne consuming eggs. Am I remembering this right?
Yeah.
You ate a lot of eggs and you were carrying a plate of eggs up the stairs?
I didn't finish it.
But we didn't finish it. Okay. So the situation, just to kind of get your head back in this because it's been a little while, Leanne has got a plate of eggs. I'm going to use this roll of tape to represent that. And she's going to carry this plate of eggs up the stairs. Okay? The stairs go across 5.1 meters. They go up 4.5 meters. The eggs have a mass, the eggs and plate put together have a mass of 1.2 kilograms. My question for you is, how much work does she do as she carries those eggs up the stairs? Huh. That's a great question, Ms. Carveling. I'm glad you asked. Do you remember what work is? Maybe we need to remember that.
Force times distance.
Force times distance, where the force and the distance have to be what? Parallel, in the same direction, right? So that's the key. Work is force times distance, where the force and the distance are parallel. So if we use that to look at this situation, so there is Leanne carrying those eggs. Can you draw a free body diagram of the eggs? What does that plate of eggs, what forces are those eggs feeling? I'm going to go ahead and draw my eggs over here. There's my plate. And then, what kind of eggs do you eat? Scrambled eggs? Fried eggs?
With ketchup.
With ketchup?
Yeah. She puts ketchup on her eggs, yeah. Eggs with ketchup is gross. Okay.
So there's some discrepancy here about the consumption of eggs. I'm going to leave the ketchup off because that doesn't sound like a terribly awesome choice to me, but no judgment if you all enjoy that. All right, so I got my plate of eggs, and tell me the forces acting on the plate of eggs. as Leanne is carrying them up the stairs?
Earth.
Earth! Which way does the earth pull or push?
Down.
Down! Same way as it always does, Miss Kay. You're right, indeed. The force of the earth on the eggs. And I'm talking about the eggs and the plate is kind of a system altogether, right? Anything else acting on the eggs? She says, yes. Which way are you pulling or pushing on the eggs? Up, right? Because if you weren't, where would the eggs go?
Down.
Yeah. On eggs. Okay. Does that help us a little bit? Remember, work is equal to force times distance, where the force and the distance are what?
Parallel.
Parallel. So what distance is parallel to the force that she's applying? 4.5, right? So the distance that we're going to use is 4.5. Even though during that stair climbing process, she moves 5.1 meters in the x direction, that's just like, I don't remember who it was now, who was carrying their plate of whatever. Was that you, Jordan? Carrying your plate, your cheeseburger or whatever, right? If you're applying a force up and you're moving in the horizontal direction, are you doing any work? What did we decide yesterday? No work is being done. Again, because the force is going up and my displacement is in the x direction. So those are perpendicular. That means no work is done. Work is only done when the force and the displacement are parallel. Excuse me. What force are you applying to your eggs, Leanne? I'm not trying to put you on the spot. Anybody can answer. Go, Ben.
Would it be 9.81? Is that negative? Because it balances gravity, so the plate doesn't move.
Okay. So you're saying that the force should be 9.81? What are the units of that?
Wait, maybe not 9.81. I'm not really sure.
9.8 times the mass.
Yeah, 9.81 times.
There you go. Yep. So the units of 9.81 are what? Meters per second squared, right? So if you ever get confused, and the reason that I wanted to draw you out and ask you that was because I want to make sure that you can process this. If you're doing a problem on homework, or if you're doing a problem on, I don't know, quiz or a test, that you can say, okay, 9.81 needs to be involved, and I agree it does. But that's not the force, friends. I have a lot of you, and a lot of people in other classes too, that just want to call 9.81 the force of gravity. It is not the force of gravity. It's even marked as meters per second squared. Meters per second squared means it's a acceleration. To get a force, you have to multiply an acceleration times mass. Remember, it's the mass, right? So let's just work this through in case you're thinking, wow, I haven't done this for a whole year. You're like, yeah, really, it was last year that we did it. Fg is m times g, right? And we know that this is an applied force. Fa plus Fg has to be equal to 0 because there's no acceleration. Remember yesterday we talked a little bit about, like, at the very beginning and the very end there is, but we're going to even that out, just talk about as she's walking up the stairs. So there's no acceleration, which means that the applied force and the gravitational force have to have the same magnitude. Okay? So I've got 9.81 meters per second squared times the mass of 1.2 kilograms. That's going to tell me the force. How are we doing? Are we okay so far? So you all should have calculators out. You're going to need them out in just a minute anyway, so go ahead and pull out a calculator if you don't have one yet, because we will certainly need one very shortly and now. So it's the mass times the acceleration due to gravity. That will tell you the force that Leanne is applying as she's walking with those eggs up the stairs. Okay? So that's the force. What was the force that you got? 11.7, I'm just going to call it. Is that okay? What are the units of that? The 11.7?
Newtons.
It is newtons, yeah. Or maybe 11.8, I guess, given what you just said, right? I'm going to change that. 11.8 newtons. And then I'm going to take the 11.8 newtons times 4.5 meters, because it's the force applied over a distance, a force up applied over a distance up of 4.5 meters to calculate the amount of work that I'm doing. How much work is Leanne doing in this case? 52 joules of work. 53?
It's like 0.974.
So let's call it 53. I'm not going to get upset because I really want to see the science, not the number. How is that going? Is that okay for you all? Okay. We're going to have to do another problem similar to this in just a minute, so I want to make sure that you are feeling good about it. We'll do that after. All right. So, one more definition we need before we can do our activity for the day. Can I go ahead and click, or are we still writing this down? We're good? Yeah? Okay. So this unit is called work, energy, and power. And the reason that I put it in that order is because that's the order we always say it in. And even your book, it has work, and then it has energy, and then it has power. But I'm just going to get power done today. Because power will take this much time, and we'll do it in the activity, and then we'll be done with it. Is that okay? Just get it done. Get it done. Here we go. So definition of power. What do you think of when you think of power? Power. You guys are too young for He-Man. Was there like a He-Man revival when you were little kids or no? Do you remember He-Man? He was like a superhero character who said, I have the power. Do you remember that? All right, somebody can like validate my memory. It was a big thing in the 80s, and then I feel like there was like a I don't know, they made the cartoon again or something. I don't know. Anyway, that's just what I always think of. Does anybody know what power is in terms of physics? The answer can be no, and I can just tell you, but I just didn't know. No. Awesome. Thank you. Power is work done over time. Literally, that's what it is. P. Now, this is not to be confused with momentum, right? We had that conversation yesterday. Stella, spoiler alert. Most people in the world do not spell momentum with a P. So I don't want you to get in a fight with one of your professors in college because they spell it wrong. Okay? So, but not to be confused with that. Power is a capital P, whereas momentum is a small p. So power is marked with a capital P, so keep that in your head because it's going to get a little tricksy in just a second, so I don't want you to get mad at me. So power is work done over time. So if we look at this equation, and again, not just to like say, sure, Miss Carlin, that sounds great. If Leanne is going to race up the stairs with her eggs really fast versus stroll up the stairs with her eggs, in which case do you think that she exerts more power or she has to generate more power? Slower?
Faster, because if you divide, if you're using the same amount of work, then the minimum time is going to get a bigger number, so that's going to be a bigger power.
Do you understand what he just said?
Yeah.
I mean, that makes sense, but like I just do it from like a gut feeling. Like, which one's going to take more work? If you are running late to my class and it's like, run up the stairs, with your backpack, right? So you're doing work on your backpack versus just strolling up the stairs because you get here after Kirkwood and you got time, right? Which one takes more out of you?
The running.
The running, right? The short time. Smaller denominator means bigger answer. You with me there? Smaller denominator, bigger answer. That's what this is all about. Takes more power to lift something up really fast than it does to lift it up slowly. Which one takes more work? Faster or slower? Which one requires more work? Doesn't matter, right? Because does work involve time?
It does not.
It does not. It does not. So work does not involve time. Power does. The faster you move, or the faster you do that work, the more power it requires and the more power you generate, depending on which way you look at it. I feel like I saw a hand over here. Yeah, go ahead.
Is this like true in biology?
For sure.
So like powers.
I mean, let me back up. Is it true in biology? Absolutely, because everything in biology is predicated on chemistry, and everything in chemistry is based on physics. So yes, but if you go ask Oz if this is true, he may or may not agree with you, because he may or may not call the same thing that I call work. Does that make sense?
Yeah.
But this principle is absolutely true in biology. Yeah.
What does Jordan's question mean? Like, what is it?
Why do you ask him instead of me?
What do you mean he's not going to say work isn't work? Like, why wouldn't he believe that?
Well, so you remember yesterday, right? Yesterday we had the whole conversation about what is work, right? And so as much as I love Mr. Oswald, he has not studied physics in a long time. Okay. I haven't studied biology in a really long time. I'm not going to talk about that. But anyway, so if you ask him what work is, he's not going to define it this way. You see what I'm saying? So the terminology might be a little different, but the underlying science is still the same. Is that okay? Okay. All right. So where were we? Here we go. Okay. So power is work over time. So every time we get a new equation, we also get some new units. So let's get some units for this. Then I've got to show you one other thing. So here's where the tricksy stuff comes. So you need to pay attention to this. So work is measured in what? Joules. Time is measured in seconds. And a joule per second is does anybody know what power is measured in? You see it on your light bulbs all the time. Good guess. Watts. Now, here's the funny thing. All the watts have power? What?
Yeah, because there's 3 of the Watt brothers in the NFL, and they're all pros.
Yeah. That's cute. I like it. Is that a thing, or did you just make that up?
No, it's actually a thing.
Okay, cool. I like it. All right. So this is why it's a little confusing, my friends. 2 things. Number 1, little p stands for momentum, right? Which we spent lots of time doing right before break. Capital P is power. We got that. The other thing that's weird is that work uses the letter W and is measured in joules. Power is measured in watts, and watts is marked with a W. Do you see what I'm saying here? It's a little bit strange. The reason I tell you is because I always have students that get it mixed up, and I don't want you to be that kid, okay? Don't be that kid. Remember that W for the unit is watts, and that's a measure of power, okay? Just like that. Thing to remember. And then, oh, by the way, I'm going to do one other thing for you just so that you've got another way to think about power, because it's kind of fun. Here it comes. Work is really force times distance, right? Divided by time. So power is force times distance divided by time. Okay. Thinking way back to what was it, September or something like that. We can also think about this. What is distance over time? Distance over time is also speed. So you can also write power is equal to force times velocity. That is an absolutely fine equivalent statement definition of power. It's kind of fun. So it depends on what you're given, right? This is why we always do this. That's why we always start with our givens. Because if you're doing a problem that asks for power and you're given a velocity, then just do this. You see what I'm saying? Don't make your life harder than it needs to be. So I would put big boxes around both of these definitions. This one is the kind of the traditional definition. This is just a, little mix up of it. Can we check the units here real quick while we wait for these people to clear out from the hallway, because that's where we're going next. Force is measured in Newtons. Velocity is measured in meters per second. Is a Newton times a meter per second a watt?
I believe so.
Yeah, because you can do this here. You've got your Newton times meter right here, right? And a Newton times a meter is a joule. And a joule per second is a watt. So you can just take it down one step at a time here. Okay. And that is equal to a watt. Awesome. All right. Questions? Ready to do some more stuff? All right. Let's do some. We are going to run stairs today. Because why not? I didn't bring eggs for you. Well, I guess I have eggs in the bag. So if you want to scramble some eggs and carry them up the stairs, you're welcome to do that as well. Okay. That makes you happy. Because I don't have a way to.
Use a Bunsen burner.
Thank you.
There you go. We could make this happen. Like if you really wanted it to happen, allow Leanne to carry her eggs up the stairs. I've got one more for you. All right, my friends. It's not really a lab, it's more of an activity, but it's fun either way. Take a look up here. You can work with one person, you can work with two people. I don't really care. This does need to be done, I'm going to say in 15 minutes. 15 minutes maximum, maybe even shorter amount of time. You're going to take a look at this. I just want you to take a look here quick. You're going to work as a team. You're going to record the equations. Don't do it yet. Just listen to me for 5 seconds and then I will be done. Okay? After that, in order to find the work needed for you to climb the stairs, I'm not worrying about the eggs now. It's you. You are climbing the stairs. And hey, did you know that when you climb the stairs, you do work? You really do because you apply a force over a distance, right? So you absolutely do work. You need to get some data in newtons. Now, I have to give my little statement here. So what I'd like for you to do is to put an approximate weight in here. But I totally understand that people have body image situations such that they may not want to write their actual weight. And I am absolutely fine with that. I'm not going to make you get on a scale and I'm not going to judge you or look at it and nobody else is going to use the data. Does that make sense? So you can write down whatever you want as long as it's reasonable. I would say anywhere from 80 pounds to, 200 pounds. I don't really care. This is really just a problem for you to do using a number. Does that make sense? I don't want anybody to feel self-conscious or like you can't write down like that I'm going to judge you based on not at all, 0%. But anyway, you're going to put a weight in there, multiply by 4.45 to get, that's your number of newtons. That's how much you weigh in newtons. Okay? And then you're going to work with your table or work with your partner or work with whoever, but I want you to work with somebody to draw a picture, come up with a plan, and then on the back, you're going to collect some data. I've got meter sticks and stopwatches. Calculate how much work and calculate your power and then answer a couple questions. Doable? All right, go ahead. Do it. There are stairs out there, as you know, because you climb them every day. Those are the stairs you get to use. Yay!